Welcome to part 4 of our series. In this section, I'll introduce you to the patented multi-level EnviroSeptic wastewater treatment system. This is a unique application of the standard EnviroSeptic system. However, rather than having a single level bed, there are two levels of pipe. One stacks over the other. Often applications with very difficult site constraints require a field to be as narrow as possible, and that's where MultiLevel can save the day. As we've discussed, the primary functions of the EnviroSeptic system are to first treat wastewater, and second, to disperse that treated effluent back to the underlying soils. Later into the presentation, we'll work through a design example to illustrate how to size a multi-level system. Let's get started. The use of multi-level systems is almost identical to single-level applications, in that they can be placed on 33% sloping terrain with a system slope up to 25%. Like single-level systems in Maine, any system sloping over 20% requires a variance. The offset to restrictive features in the water table are measured to the bottom of the pipe in the lower level. If a Presby maze is incorporated into the system's design, a reduction in the EnviroSeptic pipe requirement can be taken. The specific reduction size is based on the strength of the effluent. All the single-level bed configurations, and you'll remember those are serial, combination, and parallel layouts, along with curving beds to avoid site obstacles, are also allowed with multi-level systems. However, multi-level does have two restrictions that must be honored. Those are, multi-level beds can only be used on profile 2, 4, 5, and 6 soils, and that venting is always required. With the use of remote venting, there's often no need for the system's end user to ever see the vents. Now let's take a look at a typical multi-level field. This picture of a sloping basic serial distribution system illustrates the clear advantage in using multi-level beds. That being, the field's footprint has been drastically reduced. This is a significant advantage when working with sites that have difficult setback requirements, and might be the only solution for having an on-site septic system. In looking at the configuration, you can see that the upper level rows are offset by half of the pipe spacing. This allows the treated wastewater from the upper level rows to pass between the rows of the lower level. You'll also notice the D-box is feeding the first row of the upper level. All the rows are connected in series, with the upper level feeding the lower level by means of the drop connection, which we'll discuss in more detail later in the presentation. If this were a gravity feed system, the distribution box would not be required. And finally, the vent is attached to the end of the last row in the lower level. This is done to ensure that air passes through all the lower and upper level rows. It is especially important for the lower level rows to be aerated, due to their depth below the finished grades. Now let's look at a field under construction. In this slide, you can clearly see the upper level offset with respect to the lower level rows. The two levels are always separated by a minimum of 6 inches of system sand. We often get questions about when the inspection should take place, if one is required. With multi-level systems, we recommend the inspection take place after the upper level has been constructed and the system sand is at the top of the upper level pipes. All EnviroSeptic row connections should also be in place. The lower level does not have to be visible for inspection. You'll also notice grade stakes are being used to maintain pipe spacing. There are other techniques that we will discuss in a later presentation. These pictures illustrate a typical sloping multi-level bed using basic serial distribution. You can see the connections on both ends of the bed utilizing 4-inch PVC pipe and the raised connections. Again, the construction of multi-level beds is very similar to single-level fields, with the exception of the drop connection and required venting. As with single-level systems, combination multi-level distribution requires the use of a distribution box. The D-box in the lower left illustration is feeding 2 rows in the upper level. That then feeds rows in the lower level. It is also acceptable to configure the upper and lower levels as separate serial sections, eliminating the need for a drop connection. All the rules associated with single-level combination systems apply to multi-level as well. When the daily flow exceeds 900 gallons per day, the field must be divided into serial sections, and each section cannot accept more than 500 gallons per day. Combination systems, whether single or multi-level, are referred to as high-flow systems because the daily loading exceeds 900 gallons per day. Taking a closer look at this illustration, you can see two serial sections outlined in red. That would mean this field has been designed for a daily flow over 900 gallons per day, but not more than 1,000 because each serial section can only accept 500 gallons. As with all distribution boxes that divide flow equalizers are required for all combination systems, including in multi-level systems. You can also see in the lower right picture a multi-level combination system being constructed, with the last serial section still to be assembled. You'll remember the 2-inch rule from the prior presentation that required a 2-inch minimum drop from the D-box to the enviroseptic pipe, which kept the fluid from backflowing from the pipe into the D-box. For the same reason, a 2-inch minimum drop is required in the drop connection from the upper level pipe to the lower level pipe. We want to make sure the liquid never has an opportunity to backflow from the lower level into the upper level. It may be necessary to utilize a combination configuration, even when one isn't required, to make sure this rule is honored. For example, if the field is placed on a steep slope but only requires basic serial distribution due to a daily flow of only 450 gallons per day, the preference would be to feed the lower level from the lowest row of the upper level, as shown in the upper left picture, and have the minimum 2-inch drop in elevation. If this can't be done, a possible solution would be to use a combination system and feed the upper and lower levels separately. Also notice that at the end of each serial section is a vent stack. As with single-level fields, multiple vents can be manifolded and brought to 3 feet above the surface as a single stack. It is also acceptable to bring each vent stack to the surface separately. It's important to make sure every length of pipe is vented properly. A common mistake is to attach the vent to the upper level rows and not the lower level. Now let's work through an example. In this example, we're going to follow the same process learned from designing single-level systems, except there are separate multi-level tables that must be used in your design and installation manual. Let's review the tasks needed to design an enviroseptic system. First, we need to select the amount of pipe needed for MultiLevel Table F based on the daily flow and soil profile. Second, we need to determine the field system slope, if any. Third, we need to choose the pipe spacing requirement from MultiLevel Table G, and the final step, 4, select a pipe length using MultiLevel Table H to determine the number of rows needed and find the pipe layout width. In this example, the daily flow is 6 bedrooms, or 540 gallons per day. Right away, you should have noted this loading will not require a combination system because the daily flow did not exceed 900 gallons per day. So we can use a basic serial distribution layout. In the same way we determined the pipe requirement for single-level systems, find the design loading across the top of MultiLevel Table E on page 5 in the Design and Installation Manual, and follow that column down until you're adjacent to the soil profile, which is 2 in our example, and we can see that we'll need a minimum of 420 feet of enviroseptic pipe for our 6-bedroom loading. Now we have to decide what the system slope will be. To keep the example simple, we're going to make our field flat. MultiLevel Table F on page 5 of the manual tells us that 2 feet is the minimum pipe spacing for a 0% slope on Profile 2 soils. That leaves us with the final task of selecting a pipe row length. We're going to use 70 feet. Let's go to MultiLevel Table G on page 6 of the Maine manual to find out how many rows will be required and what the resulting pipe layout width will be. MultiLevel Table G is used in exactly the same way the single-level Table C is used. We find the pipe row length we selected in the far left column and then move to the right until we find the feet of enviroseptic pipe required that was determined from MultiLevel Table E. You then move down that column to find the number of rows that will result from our pipe length. To find the pipe layout width, continue downward in the same column until you are adjacent to the pipe spacing being used to find the pipe layout width. Now let's find our field's information. In our example, we're using a pipe row length of 70 feet. Finding that in the far left column, we move right until we encounter at least 420 feet of pipe, at which point we move down that column and see that 6 rows will be required at 70 feet in length to satisfy our minimum 420 foot requirement. Continuing down the same column until we are in line with our required minimum spacing of 2 feet, we find our multi-level field will have a pipe layout width of 6 feet. In the same way that the pipe layout width represents the outermost edge of the first row to the outermost edge of the last row in a single level field, the pipe layout width for multi-level fields will span the upper and lower levels. By that I mean the outermost edge of the first row will be in the upper level, while the outermost edge of the last row will be in the lower level. Let's summarize the field we just designed. For our 6-bedroom daily flow, or 540 gallons per day, we will need 6 enviroseptic rows, 70 feet long, with 3 rows in the upper level and 3 in the lower level, spaced 2 feet center to center, resulting in a pipe layout width of 6 feet, and utilizing basic serial distribution. Let's take a look at an illustration of this field. Here are 2 cross-sections of the multi-level field we just designed. You can see the upper 3 rows are connected in series with the lower 3 rows by means of the drop connection. The end of the last row in the lower level is connected to the vent stack, ensuring all the rows, starting with the lower level, will receive airflow. Another point of interest is how the fill extension is measured from the edge of the upper level, not the edge of the last row in the lower level. If this field had been designed with a system slope in excess of 10%, a 3-foot system sand extension would have been required on the downslope side. As with single-level systems, that system sand extension would only need to be 6 inches thick to simulate the system sand below the lower level pipes. If this field had used a pump to deliver effluent to the field, differential venting would also be required. Again, the same requirement imposed on single-level systems. And finally, notice the overfill requires a 3-to-1 slope. It is common to request a 2-to-1 slope waiver for level fields. As with single-level systems, multi-level systems can be configured using unique bed layouts to meet demanding site constraints. By that I mean, multi-level systems can be arranged to curve around obstacles or arranged in any number of unique shapes, including triangular. The system pictured here is such a configuration. It represents a high commercial daily flow that had to be laid out in a triangular shape to conform to the limited usable land on the site. You can see from this drawing the field was quite complex, but never violated any of the design requirements for multi-level systems. Although the field has an unusual footprint, it has the required number of serial sections for its daily flow, with each having the minimum required amount of pipe for each section. The row lengths within a serial section are allowed to vary as long as each section has the same total amount of pipe required. For example, if a given daily flow required 1,175 feet of pipe, with 5 serial sections, then each serial section must have at least 235 feet of pipe. If due to site constraints we couldn't make our field rectangular with all the rows the same length, and instead had to use a triangular shape as we did for this McDonald's system in Alton, New Hampshire, row lengths will vary from section to section. This is acceptable as long as the total amount of pipe within each section is at least 235 feet. So to illustrate, one section could have 5 rows, with the first being 60 feet long, the second 55 feet, the third 50, the fourth 40, and the fifth 30 feet long. The total amount of pipe is 235 feet, which satisfies the rule. The unusual shape will have no effect on the treatment capability of the field, as long as all of the serial sections meet this footage requirement, which will result in a balanced daily flow throughout the field. That brings us to the end of our discussion on multi-level systems. So let's review the highlights of what we learned. We began by discussing the benefits of using a multi-level design, and how the use of multiple treatment layers results in further reduction in system footprint, while still allowing the diverse bed configurations and unusual shapes allowed by single-level enviroseptic systems. They are, however, limited to soils with a perk rate of 30 MPI or better and must always be vented. As always, feel free to contact our technical support staff for any assistance. Now let's take a look at what's coming up in the next section. In our next section, we'll discuss installation issues like site preparation, proper assembly of system components, several methods of maintaining pipe spacing during backfill, where flow equalizers should be installed, and finally venting, including how to install remote venting.